So we've talked about pointers and the fact that we can have pointer formal parameters, which will allow us to pass pointers as arguments to functions. Now we can also return a pointer from a function. This allows us to allocate dynamic memory, so create dynamic variables in a function or dynamic arrays. Then we can return a pointer to that, to the calling function. Quick note here, you cannot return an array from a function. You can, however, return a pointer to a static or dynamic array from a function. So you can return static local variables or pointer formal parameters. Is a quick example. You have the return type, so integer or float or some struct, for example. Then you have the asterisk for the pointer and then the function name. And maybe the function has a few formal parameters between parentheses. So the main thing here is what you return. In this case, a pointer to some return type. Now it's important to note that it is an error to return a pointer to a local variable, so just a regular stack variable, right, such as function parameters or variables declared in the body of the function. And at this point you should understand why. So as we've discussed previously, the local variables go out of scope, so when you return from that function to the calling function, in other words when that stack frame gets popped off of the stack, then the local variables are basically destroyed. So there's no use in returning a pointer to those. It's an error to do that. In this quick example, I have a function called createDynamicInt. The goal with this function is to create a dynamic integer on the heap and then return a pointer to that. You can see it returns a pointer to an integer, and the return statement here, you can see return new int. This, by the way, is how we can initialize a variable. So you use the parentheses and then you pass it the value. So I pass it 5. That's going to initialize that dynamic variable to 5. Okay, in main I have two pointers, int pointer 1 and int pointer 2. Those are both pointers to integers, and you can see how I initialize these pointers using the createDynamicInt function. All I'm going to do is I'm going to print both of those out. So using the referencing as you are familiar with already, then I dereference int pointer 2 and I set that to 100, print it out again, and then I'll simply delete, or in other words, deallocate the memory where those pointers are pointing. Alright, I'll build and run that, and we'll see what we get. In the initial two console outputs we get 5 and 5, and then the second pair we get 5 and 100. Remember, it's int pointer 2 that I dereference here to change it to 100. So this is what you do not want to do. It is an error to return a pointer to a local variable. I have a local variable here called temp, so int temp. Then I have a pointer, ptr, so a pointer to an integer, and this stores the address of that temp variable, and then I return that pointer. So I might return some address, but once the stack frame gets popped off of the stack, then essentially this local variable does not exist anymore. Let's actually build this, and you can see you get a warning. Returning address of local variable or temporary temp. So again, you don't want to do that, and you also don't want to return the address. But in this instance, this is not legal because we are returning an address of a local variable temp. So local to the function createDynamicInt. Okay, so these are some of the things that you do not want to do. In some of the following sections, I'll talk about the static keyword again, and also how you can return a pointer to an array. Okay, another quick demo. I have a function called createStaticArray that will return a pointer to an integer again. And in this statement, I have an array called staticArray with 5 elements. This is a static array of integers. Now remember, with a static variable or an array, that is going to exist for the lifetime of the program. And so of course that is different from a local variable that is going to get destroyed once we are done executing the function and return to the calling function. For that reason, we can return a static variable or a static array of variables, or should I say we can return a pointer to one. So that's what I do in main. I have a pointer to an integer, and I call the function createStaticArray, and I do console output ptr, and I use the subscript notation instead of dereferencing it, and I pass it 0. Just a basic demonstration on this. Build and run, and we get 250 printed out. And the same thing if this was a variable. Now of course I'm just demonstrating using an array here, but you can go and try this with a variable. Next, what I want is a dynamic array. I'll remove the static keyword and this here as well. Now I'll need a pointer here, so a pointer to an integer. This is where we create the new dynamic array, new int, and we specify the size. And we can use subscript notation with that, and we set that first element to 250, and I'll simply return that as well. You can change the function name if you want. I mentioned there's actually a space in memory where the program will keep global and static variables, and as I also explained, you have a space called the heap for dynamic variables, whereas regular variables such as your pointers and everything will be stored on the stack. And once you pop the function off of the stack frame, the local variables are destroyed, but then the object will still exist in the heap. And we are going to return a pointer to that object on the heap. Here we have a pointer to an integer, we are returning a pointer to an integer. And we are assigning that here, right, using this function. And we just print that out. Actually, one thing before I run this program and end the section off, you want to go ahead and delete the array that the pointer is pointing at, or in other words, to allocate or free up the object that that pointer is pointing at. So you have to think about what the pointer is pointing at. This will not point to a regular variable, this will point to an array. Right, because that is what we create right here. We allocate a new dynamic array on the heap, and we need to deallocate that using this notation right here. Okay, I'll build and run, and that should print out 250. Okay, and that works fine. I have another demo for you. At the top I have a struct player stats, and you can have multiple stats in here. I'm just gonna keep it concise and just add one, so int score. I'll go to the main function. Here I declare two players, so player 1 is a pointer to player stats. Same thing with player 2, so I create dynamic objects on the heap here. Player 1 will point to a player stats object on the heap that has 5, so score here will be initialized to 5. Player 2 will point to a player stats object on the heap and score will be initialized to 10. Then I declare another pointer called winner, pointer to a player stats, and I call this function getPlayer with greatest score, and I pass in those two pointers. Let's look at the function. This returns a pointer to a type of player stats, and of course that can be null. So you can see I actually return null pointer here. Get to that shortly. In the parameters we also have two pointers to player stats. I just call that PL1 and PL2 for player 1 and player 2. And of course I just do some basic comparison. So if player 1, and we get the score from that, is greater than player 2 score. So again, the arrow operator, we use the arrow operator instead of the dot operator here because these are pointers. So if player 1 score is greater than player 2 score, then of course we return player 1. Otherwise we return player 2. Otherwise we're going to return a null pointer because we basically won't have a winner in that case. It is a draw essentially. If I scroll down to the main function, right here, you can see what I mean. So if we don't have a winner, then this will be initialized to null pointer. If winner is player 1, then we go and print the stuff out, and the winner is, and then player 1. Then we print out player 1 has winner score. Again, using the arrow operator instead of the dot operator. Remember, winner is a pointer to a player stats struct, right? So many points, so it has so many points. Otherwise, if winner is player 2, then we basically print out player 2 information. Otherwise, we have a draw. And down here, I just delete those pointers again. So remember, player 1 has 5 points, player 2 has 10 points. So expect player 2 to win here. And the winner is player 2. Player 2 has 10 points. Alright, I'll change this. So player 1, I'll set that to 15. And of course, you'll go through and test your program in this way. Player 1 has 15 points, so the winner is player 1. Set both to 15. And it's a draw. You can also check for null pointer. As explained with the if else statements, you don't really need the final else. So I'm just doing another else if statement. And I'm checking if winner is equal to null pointer. Then it's a draw. and you'll see that it'll work fine too. So you can actually do a check to see if a pointer is a null pointer. Alright, so this was just another quick silly demo for you. I wanted to throw in structs again and dynamic objects so that we can use the pointer operator again. Instead of just comparing regular variables like integers or something like that, I wanted to do something different for a change. Okay, so I hope you find this useful, and I'll see you next time.